Scott is a water resources specialist at Wisconsin Department of Natural Resources in the Division of Environmental Management, working in the central Wisconsin area. For the past 20 years, he has provided support on a variety of subjects, including aquatic invasive species, blue-green algae, critical habitat designations, and works with lake and river planning grants and TMDLs. So some of the questions around septic systems and lakes, I'm hoping that Scott will be able to cover some of that information for folks that have been asking questions about those things. And Scott, we can see your screen. I am going to unmute you so that people can hear you. And if you unmute yourself, Scott.
All right.
Yep, we can hear you. We can see you. You should be good to go.
Okay, thank you. My name is Scott Provost. I am a DNR employee, but I also do a lot of soil testing on the side, where occasionally I have to give folks like Mark Fingers a call from the state and work closely with them. Good group of folks that really know this stuff inside and out. So anyway, let's talk about septic systems, or POWTS. By the way, those are the same things. We used to call them septics until the last code changed, and then they changed their names to the private little wastewater treatment systems. But for this talk, we can call them septics if you want. Let's see here. Oopsie. Are you seeing any advancing of the slides?
Not yet. If you hit the down arrow or click the mouse.
Yeah, I am. Oh, there we go. Thank you. All right, so just briefly covers how these functions, how the system functions. Your waste comes out of the house, goes to a tank, and that's an anaerobic system. So it's mostly bacteria get in there and they break stuff down. They try to get rid of some of the solids, and that's really critical that all your solids stay in that tank, and that they don't go out to that drain field. That's how you're going to fail a system. And Mark said this, and I really want to reinforce this, that septic systems are a biological unit. They're not a mechanical device. And these things live and die. So you have to, and if you want the longevity, then you need to treat them decently. And those tips that Mark gave you, they definitely work, every one of them. So anyway, the water comes in here. There's some anaerobic treatment of the bacteria that takes place, and then a clear, like a translucent, clear, semi-clear liquid goes out into the drain field, and that's kind of a quasi-oxygenated system. And Mark mentioned that 36-inch separation distance here. That's important. If you have 36 inches of soil, of unsaturated soil, that reduces about 95% of your bacteria and viruses. And a lot of your phosphorus can absorb to some of the metals out there, such as a natural occurring iron, magnesium, calcium. But your nitrogen is a kind of a different character. There's different states of nitrogen, and through the chemistry and the nitrogen cycle, certain things can happen. And sometimes you get what they call denitrification, and that's a good thing. That's when your nitrogen from an organic form ultimately gets converted into nitrogen gas and goes up the atmosphere. And it's not a big deal. 78% of the Earth's atmosphere is nitrogen. But along with that comes some methane and sulfides, hydrogen sulfide gases, different forms of sulfide gases. So that's your stinky part. All your stinky stuff, our humans are just as able to smell that sulfide as like a dog, because we evolved around it. It usually means there's decayed food there, and if you were too dumb to eat it way back when, those genes died out. So we're pretty sensitive to that smell as well. Another way, then all this water eventually reaches the water table and flows in whatever direction the groundwater is going. And that's important, because especially around the lake. So all POWTS around the lake important. It all comes down to location. And we'll get into that in a second. So if you're in an area of the lake that say is real shallow groundwater or higher groundwater, that makes a difference on how that system performs and how it affects your lake. Maintenance is another thing, and Mark also talked about this. You have to maintain that system. If you don't, it's going to fail faster than it should. It's not going to treat water like it should. So pumping the system, most counties, I think all counties now have a what they call a maintenance agreement. When you will not get a sanitary permit unless you sign one, which means you're going to pump your tank every 2 to 3 years, depending on what it's set up for. And some of the aerobic units may have up to 6 months maintenance where they have to be checked. But for all practical purposes, if you have a septic system, you get a letter from the county saying, hey, it's your turn, it's your time to pump your tank, pump the tank. If you don't, some counties will have it pumped and then bill you. You don't want to go that route. You're going to lose every time if you try to fight it. So, and it's just good, good management to maintain. Another critical thing is design and installation of the system. Not all systems are equal. You know, you're using soils, and as Mark showed in that one slide, the soils vary considerably across the state. And then Septisol, which is like a sandy soil without much soil structure, versus an alpha soil, which can have clay loam content, and it has less permeability, and the structure is very important on those soils. You have to design a system, or you should be designing a system appropriate to those soils. Back in the day when I first started doing septic stuff in the early 90s, there was these, the old code had a lot of what they called a cookbook mound, where it was basically used as an example. So all the plumbers who were putting systems in learned that example, and that was on their tests for their certification for their licenses. And they ultimately put in a lot of these 8 by 47 foot mounds. It didn't matter if it was on sand, clay, what, they just did it. What happened is any failed mound that I ever gone to in my 25 years of doing this stuff has always been an 8 by 47 on heavier soils. It gets, because it was just, it's not a good design for those types of soils. It depends, you want to be longer and narrow and not necessarily wider and shorter. And then the other important thing, I'm glad that Mark and I are on the same page, because he's kind of like the boss out in the field. So this works out good. So far we're jiving, no major disagreements. The last thing is it functioning? Mark was talking about that. You know, be very careful. I'll hit this later towards the end. But just saying the system is functioning, is it? Yeah, it could be functioning hydraulically, meaning it's getting rid of water, but is that because the bottom's rotted out of the tank, or is it because as you got a straight pipe to daylight somewhere? You know, you could drive down the highway and you see all these straw bales going out to the ditch from the house. Well, that's because there's most likely over a failing septic line that's daylighting right to a ditch, where I've seen kids playing. On one site, a guy even built a nice little bridge across his little open water sewage ditch so his kids can get to this playground equipment. And then you want to make sure that it's code compliant. You know, just because it's functioning hydraulically doesn't mean it's functioning according to code, meaning it has that 3 foot separation distance that's needed, or it might be too close to a well, because a well was put in, you know, too close to the system, or vice versa. So here's that location thing. If this is your house here, say this is Mark's house over here on top of the hill, and the zone of groundwater discharge, or groundwater is discharging this way. It's coming in from the lake, or coming in, going into the lake, and his plume's right there, and his brand new system. But you know, it's treating, it's doing what it can, it's up to code, but you're still going to have some nitrogen that reaches the groundwater, and it's going to go to the lake. And I'm over here on this side of the lake where groundwater is leaving. My system's old and it's not in good shape, but I'm too cheap to replace it. I do everything I can at night to make it work. But it's not having an effect as long as it's not overflowing the ground and flowing into the lake. When it hits the groundwater, it's not having any effect on that lake. So if you're interested in, is my system having an impact, or our septic systems having an impact on the lake, you need to define which way groundwater is flowing, so that way you can determine, all right, we should probably concentrate our efforts on the zones, or in the area where groundwater is discharging, and an area where groundwater is recharging. We'll worry about that later, unless there's something with surface flow. So then back to maintenance. Want to do at minimum a triannual pumping. That's, it's just not a burden from the county or from the state that says you have to do this. This is a good thing. You want to do this. And be cognizant of what you're disposing. Some of this, remember, these are biological units. Too much bleach, sometimes even, dumping medications down can have a profound impact on the bacteria in there. And that's how your system works. Just like our guts, we have to have a bacteria population in our systems to digestive food, whatnot. It's the same thing with bacteria or with septic systems. They are a living unit. Another good thing to do is fix leaky plumbing fixtures in the house, especially on older cottages that may have a leaky toilet or that dripping. Sometimes you have a slow trickle going out to the drain field. Doesn't sound like much. If you put that over the year, that's a huge increase of water. And Mark was talking about overloading the system. And that can certainly happen. Some of those old toilets out there on old cottages might, when they pump or when they flush, they're flushing 5 gallons of water at a time, when a new toilet is only flushing 1.6, and it's performing just as well. So it can really save on your system to use water conservation fixtures as well. Whoops. Here's as a soil scientist, this is the one that really irks me the most, is when the system isn't designed according to the soils. You need to know, you need to have an accurate soil test. Those old perk tests from the past, they missed way too many things, and it led to a lot of improperly working systems. Now with the new code and the research that Mark was talking about that came out of UW-Madison, we know a ton of information. We have a ton of information. We know a lot of stuff on how to manage these things. So what you typically do is you get somebody to come out, do a soil test. And in our area, in the Central Sands, we're around our lakes and streams, typically it's a sandy soil. So, we assume each bedroom has 100 gallons per day coming out of the house, not the number of toilets, not the number of fixtures in the house. It's based on the number of bedrooms, assuming there's 2 people living in that are capable, 2 people living in each bedroom per year. So each person generating 50 gallons of water a day times 2 is 100 gallons. Then we design for 1.5 times that flow. So a 3-bedroom home, ultimately we have to design for 450 gallons of water a day. It sounds like a lot, but you'd be surprised how fast that can be reached. Say you had a party at the house or something like that. So you want to make sure it's designed for not just the bare minimum. And then we use every soil loading, or every soil has what they call a design loading rate. And it's, as Mark was showing, it's in this particular case, it's 0.7 gallons per day per foot squared, meaning that's how many gallons of wastewater I can put a day on a square foot of that type of sandy soil. And then it's a simple, and this comes important here, it's a simple calculation. You take your waste load, divide it by your soil loading rate, and this tells you how many square feet of distribution cells is needed. So in a typical 3-bedroom house around here, we need at least 643 square feet of area of drain field. Doesn't sound like much, but it's a little trickier than that. So when you're siting these distribution cells, you need to identify all setbacks, and that's the distance between your drain field and something like a property line, a well, a house. You got to be 5 feet off a property line. You got to be 50 feet from a well, and you get you factor all these things in when you do the soil test and you survey it all out and you draw up a plot plan. It's like, great, I just got to figure out where I got to get 650 square feet in. Well, after you add in all the setbacks, you find out, it's going to get pretty tight, because you just can't put a box out there that says, a square box. Here's my 643 square feet. There's certain design criteria you got to follow, like the width of a cell can only be 10 feet wide maximum, things like that. So anyway, and you want to make sure you know where the well is. If you're in sandy soils and your well is downgrading or downstream of that septic system, I'll leave that up to you. That's pretty obvious what's going to happen there.
Scott, I think we lost your sound.
Oh, sorry. Yep. I apologize. My mute button on my cord went out. So like I was saying, I don't know where I left, but the well location is important. You don't want your well necessarily to be downgrading or downstream of a septic drain field in sand country. You'll get you'll understand why. I mean, it doesn't take a genius to figure that one out. Vent locations are important because there are gases coming out. You don't want them necessarily real close to a window, like a bedroom. So in the summertime, you got it open, you got a little breeze coming in. He's like, what is that? Well, it's last night's dinner coming your way. Uh, know where you're going to place that system, especially on lake lots, because you may want a deck out there, and you can't put a deck over a system. So you want to make sure you're planning for all that stuff in the future. Maybe I'm not going to put a garage up yet. Well, I don't intend to. Well, you might want to in the future. So make sure you're putting that system in a place where that's all accounted for. So good planning goes a long way. And back in the old days, replacement area on new construction was required, but today they're not on conventional systems. I still recommend it on conventional systems just because it just when it comes time to replace that drain field, because they're all living organisms, they're going to die. Those that will get you into a newer system faster and quicker. And your design, the longer and narrow, the better off you are. Oops. Small lots in a big house. This is where we are now around Wisconsin lakes. If you don't have the necessary area, what do I do? Well, there's one option, that's holding tanks, and that's where no water leaves anywhere. It stays in this concrete box. You call and get it pumped. It costs you 150 to 200 bucks a shot. And when that tank is full, it does not go to the lake. It does not go to groundwater. It goes to the treatment plant. Say I don't have enough room, but if I could go with 3 feet instead of 5 feet from a property line, I could do a code variance. Sometimes I can use the flow data that I actually have, or you could use flow data if you have a flow meter on your system and redesign accordingly. Or you could do what they call individual site design, which is what happens a lot in the Tri-Lakes area in Adams County and a lot of the small lakes around here in central Wisconsin, because the lots are so small. And those you got to call somebody like Mark to come out, and you got to get the state involved, and they come out and look at it and say, oh yeah, let's do this type of system. You collaborate with them, and we get you a decent system to fit in there. But there may not be a component, what they call a component manual to that system, but we definitely can get something in there. And if you're going to do a verification on POWTS around the lakes, have a plan. You got to have a plan. You just don't hire somebody to go out and just do what quote unquote tests. Have a good plan in place, and that plan should cover the follow recommended guidance by Department of Commerce and DNR on how to sample those, or how to do a good verification. Dye tests back in the day, those are unreliable. Don't waste your money on them. The only thing they're going to tell you is which way groundwater is flowing. You could have a brand new system that's still have the dye go through it hit the groundwater. A couple of days later, it's showing up in a lake. They are useful when you have a direct discharge, like a pipe to a lake or ditch. Then that's fine. But what happens when you do dye tests without full disclosure is somebody sees dye and they just automatically assume my next door neighbor's system's bad. Well, it doesn't mean that necessarily. So make sure you know what's going on with those dye tests and shy away from them. Identify the groundwater flow directions. That's important. We talked about that. You want to concentrate on the areas of first where groundwater coming in first. You want to incorporate the county office and make sure they know what's going on. And you want to, there's different models you can use to help determine what other land use inputs are having an issue with them. You want to quantify the nutrient load. So if the septic systems only are making up 10% of the total nutrient load to your lake, why would you consider going to septics to a treatment plant type of system, or a different collection where there's further treatment when 90% of your nutrient load is coming from something else? So, because you hear that a lot, like, why don't we just put a sewer in? Well, besides costing a lot of money, it may not be productive. So when you have your surveys done, you want to know if it's functioning, if it's accepting wastewater. You want to put a little bit of water in. You got to make sure it's working. Don't overload it, but and you want to do borings in and around that drain field on the edge. Some realtors I worked with just want to scratch and sniff, where you go out there and you look down the vent and you see if it's working. Yeah, don't do that. That's not an inspection. Make sure if you're going to do it functioning properly, especially if you're buying a property on a lake, make sure it meets these. It's sized appropriately. It's got that 36-inch separation. Hire a CST or a plumber or somebody to come out and look at it. Yeah, because you're not required to have an inspection for a real estate transaction. So, but if you're going to spend that kind of money, it's well worth a couple $100 to have somebody come out there and tell you what you're looking at. And here's a real important thing to consider is, oops, I'm going to go through these quicker, run out of time. Don't forget other sources. The POWTS can be a significant source of nutrients. Maybe it's not, but don't forget about lawn fertilizers or runoff from dryways, rooftops, etc. Animal waste, or what's coming in if you got a large watershed, what's coming in that way. It's a holistic approach. You got to think that way when you're doing your nutrient budget, and find out, this is important, the POWTS. And so a lot of times you're going to find out, folks, on these lakes that are highly developed, your lawn fertilizers put in more nitrogen, phosphorus than your septic systems do. So, and in some cases like this here's a perfect example of it. There's a lot of homes on this channel that's all sewered. There's not one septic system going to that channel. But what we do have is a ton of nitrogen use on these lawns. And when that nitrogen hits the water, it works just like it does on grass. A lot of your aquatic plants are monocots, like grass. It loves nitrogen. You can't give it enough. It may not increase the number of plants, but it's certainly the biomass of the plants, or how much material is out there. So, okay, one last slide here. When you do a plan, or you do a large scale like septic system survey, you would determine the loads before you even think about considering a sewer. And if you're going to do this, be prepared to implement recommendations of that plan. So that means you're going to have buy-in from the residents. If all of a sudden everybody's screaming they want an inspection on septic systems, and they find out, oh, it's yours and it's going to cost me another $15,000, I'm not going along with that. So make sure they understand that if we do the survey and we find a bad system, we expect something to happen. You can work with the town or the county with your ordinances. There's other avenues for information from the state and from your private consultant. And when you get into this, make sure you find out, you can answer this question: is who's paying for this? Because at the end of the day, everybody's worried about water quality on their lake, but they also worry about their pocketbook. So make sure you got that buy-in. So that's I'm gonna cut it short. So
That's all great information on both your parts. I think as the questions were coming in, some of the questions that people had, you definitely broached or covered a little bit, Scott. I think in the interest of time, I'll list one question that I think was largely unanswered by the presentations, which is, what happens? You talked a little bit about the functioning of a septic system, how they treat biologically, they remove pathogens, do a pretty good job for things like phosphorus, but other things like nitrate and pharmaceuticals might be able to get through. But the question of pumping those tanks, the settling of the solids, what happens when pumps are required to be, or systems are required to be pumped? Where does that waste go? And what agencies are responsible for kind of overseeing that part of the wastewater management of these systems?
when they pump a system, your septic pumper has two choices. One is to take it to a treatment plant and they'll discharge it there, and it goes to the treatment plant, which they have to pay the treatment plant to dump. And a lot of treatment plants don't like septage versus holding tanks, because the septage can have stuff sitting in there for 2 or 3 years, and that's pretty biologically hot, and it can screw up their system if it's a smaller large scale, smaller wastewater treatment system. If it's a big wastewater treatment system, it's buffered against that. But sometimes you can give it a shot of BOD that stuff that's in that tank that can screw up the bacteria colony in that larger treatment facility. whereas holding tanks is more of a, you don't have that. The other sources, it can be land spread. It goes through a process. These pumpers have fields out there for farmers that they talk to. They get the field approved through the Department of Natural Resources. They have to line that waste. They make sure the pH is above 11, I think. Is that right, Mark?
Yeah, I think it's above, yeah, it's 10 or 11. Yep.
Yeah.
Or 12.
So,
I'm sorry. It's 12. It's got to be
well,
above 12.
so it's really alkaline, and that causes a lot of the nitrogen right there to go off as gas.
Right.
But
And
then-
it kills all your bacteria
Yep.
and all your bacteria and viruses.
It kills that because the pH is too alkaline, and then you land spread it, and what's left there is used as a fertilizer on the soil.
Thanks for providing that overview of that piece of the process. We are, in the interest of time, we're a little bit over. We're going to have to end it there. I would like to thank both Mark and Scott for presenting today at Wisconsin Water Week. We are moving in or kind of honing in on lunch. We will resume sessions later this afternoon. I hope that many of you will be able to join us for those afternoon sessions. With that, we're going to end this session and have a great afternoon.